Hello, welcome. Today I would like to share some tools, tips, and tricks in Chrome Developer Tools that will help you build better and faster web apps. These are tips that I find useful and I use every day, and we're going to touch on a little bit of everything: networking, JavaScript performance, rendering, and other kind of deeper tools within Chrome DevTools. So without any further ado, let's get right into it. We're going to have two parts to this presentation. So in the first one, we'll talk about the high-level features available in Chrome DevTools. These are the tools that you'll be using every day on your pages or on your apps as you're building them. And then part two will be a little bit deeper, going into how does Chrome DevTools work, how can you extend it, how can you customize it, and do some really awesome stuff. So I encourage you guys to check out both videos. But to start, you can follow along by viewing these slides on your own. And in fact, I encourage you to do so after you watch this, because it's one thing to just watch somebody do it and then to try it yourself. So grab the slides later, but let's get right into it. So first, we have the elements in console view, which of course everybody will be familiar with. You've used this every day. And a couple of things that I've actually just recently discovered myself is that you can drag and drop elements in here. And there's a couple of very nifty features for debugging. So for example, if I right-click on this element here and I go into inspect this element, we have our li here. Let me just scroll up a little bit so we can see what we're doing. And we have this delete me element. So I can actually drag this up and change its position, which is quite nice. And because we have this element selected, we can also do $0 to view the element itself. So very nice for debugging. All of that's is kind of neat, but this is what really interested me when I discovered this. So we have this element called delete me, and we have the delete button. And oftentimes you're doing some sort of AJAX interactions or building an app, and you're trying to figure out, what's causing some certain event, what's causing a certain element to be modified in the DOM. And in fact, you can do that very easily. You can discover what's happening by right-clicking on an element, going to break on, and in this case, I'm actually going to remove the element, so I'm going to say on node removal. But you can also do on any subtree modifications or anything similar. So I'll set a breakpoint in here, and when I click delete me, you can see that the page actually paused. It says pause in debugger, and it'll show us the specific element or the JavaScript file, the function that's causing the action to occur. So if I hit continue, it'll delete that element. So nice and simple, very, very useful if you're building JavaScript apps or anything that modifies the DOM. And speaking of which, before we get too far into the specifics of the tools, a couple of tips. First of all, definitely check out your settings. There's a lot of very nice features in there. And some of those features don't make sense to have on all the time, but sometimes they can be invaluable. So for example, I do a lot of optimization of first page loads, so trying to figure out how we can accelerate the loading of the page. And for that, I find disable cache as one of the most useful features all the time, because I often wonder, did I reload this page correctly? Did I fetch that resource out of the cache? Because that could be skewing the results. So when you have that checked on, it means that anytime you have the DevTools open, Chrome will not use the cache. It'll always fetch the resources from the origin page. Now, if you close your DevTools, it'll continue using your cache. So that's actually something you can keep on, and it'll work just fine. So don't worry about disabling all of your caches. We'll talk about show paint rectangles. This is an awesome feature, very important for rendering performance. If you are building an app that is AJAX heavy, a lot of modifications within the app, logging Xmlhttprequest requests is actually very useful. You can, of course, see the outbound requests in your network panel. But if you have this enabled, you will actually see Chrome log the events, the HTTP requests into your console, and it'll actually print the object there so you can open it up and look at some of the parameters. So your mileage will vary based on what kind of applications you're building, but may be interesting to explore. And then the last one that I'd like to highlight, because this bugged me for a little while until I discovered this option, is that Chrome tends to reformat your CSS markup or the colors into RGB by default. Whereas if you're using hex, then if all of your code is originally in hex, you would like to see it in hex. Well, you can tell it to preserve it, or you can actually make it switch into a different mode like HSL, which allows you to use the color picker right within Chrome to get nice changes done right within Chrome DevTools. if you're trying to find a lighter shade of a color or something similar. So moving right along, network timeline. This is the bread and butter of a lot of the work that I do, so I spend a lot of time in it. And one of the things that I know that happens to me is after a while, there's a lot of information hidden in here, and it just kind of gets lost on you. So I like to kind of bring back the attention on some of the awesome features that are hidden in here. So for example, we have, if you look at the size column in here, we have size and content. And maybe this is not the most intuitive way to explain it, but if you look at this, it says that this page, the size of this page is 10 kilobytes, but the content is 41 kilobytes. What does that mean? Well, it means that we've transferred 10 kilobytes to fetch this page, but the actual resource is 41 kilobytes, which means that we are actually using gzip. So we fetched 10 kilobytes that got expanded on a client and all the rest. And in fact, you can see that this applies to virtually all the resources, which is great. It means that gzip is on. We're using compression, which is a very good optimization. But then you scroll here to the bottom, and you'll find that we have our Google Analytics snippet, and it only fetches 35 bytes, or the content is only 35 bytes. But there's 855 bytes of HTTP overhead, if you will. And that also makes sense because this is simply an analytics beacon. So we're sending data to the Google Analytics service. It just returns a 204, and there's nothing wrong here. But very quickly, you can diagnose if any resource is not getting properly compressed. That's the place to find it. The other and very similar view that's worth paying attention to is the time column. So here we have, once again, two elements, time and latency. So time is the total duration to fetch that resource. So for this specific page, it took 1.18 seconds. But the latency is the time that it took to get the first byte of that response. So for whatever reason, we were waiting for 1 second. Maybe that's a new TCP connection that needed to be established, so we needed to do the negotiation and hence the delay. So you can see that, for example, in this case, we spent most of the time waiting on the network, and then once the request got fulfilled, it actually came back very, very quickly to us. Now, the last bit that I find incredibly useful, but perhaps is not the most intuitive, is I'm going to flip to this page here, just a random page, and looking at this waterfall, we get the timeline of how the resources are loading. But you can actually click on the timeline and sort it by a different metric. So for example, we already talked about duration and latency. So if I wanted to find out which are the resources that were queued the most or were waiting the most for the network to respond, I can click on latency, and it resorts all of the resources in this timeline and shows you that, hey, this photo file that we were fetching, we were waiting for 1.46 seconds. There was some connection time, SSL time, etc. And then the actual resource fetch was basically a no-op. So very, very useful. You can find very interesting performance bottlenecks by using this. And likewise, we can resort this by duration, which is the total time. So this is combined waiting on the latency and fetching the resource. So for example, this JOT file, which we're fetching from Twitter in this case, 357 milliseconds to do the DNS lookup, which is quite a bit of time. Then kind of a waterfall of all the other metrics for connection and receiving and all the rest. So very, very useful. Let's go back. Similarly, in the same timeline, we actually have two very useful tips for figuring out how the resources are getting scheduled. So when the server responds with data, so whether that's an HTML file or JavaScript or CSS file, the document parser or the browser picks it up and tries to figure out what other resources are required. So the browser schedules these resources. And here we can actually show you that some resources are being scheduled by the document parser and some by scripts. Now, why is this interesting? It's interesting because in order for something to get scheduled by a script, the script needs to be downloaded, it needs to be executed first, and only then can the browser fetch these resources, which is fine, but it hides a lot of the information away from the browser. So in that case, the browser can actually help you accelerate these downloads. If you just have the resources directly in your HTML, the browser can be actually very smart about how to schedule those and preemptively fetch those resources to avoid slowdowns on the page. So it's very popular now to use JavaScript loaders. Those are great. They can offer a lot of great features, but you're hiding some of that information. And we'll come back to this in a second. So after you look at the network timeline closely and you kind of drill into the specifics of where am I spending my time, is it the latency, am I blocked in the server, and other things, you start to observe patterns. And it's actually quite remarkable, because after a while, it doesn't even matter what the specific pages you're looking at. You just see patterns where you quickly figure out and narrow in on, like, okay, well, I have a blocking JavaScript file which is doing a document write, which is blocking something else. So as an example, I have this seemingly incredibly simple example here where we're fetching two resources. It's an HTML page, and as you can see, now we know how to read this. It takes 1.5 seconds to fetch this entire HTML page. But the latency is very low. It's 9 milliseconds, which means that we send the request and we get a response almost immediately. Or at least we don't get the full response. We get some part of the response. So the server gave us some data, but it's still processing the rest. And based on this data, because we're scheduling the styles CSS file, it means that that data that got served contained a reference to this style sheet. So that already tips off the browser to go and download this file. But this file, the style sheet, has a very different performance profile. So in here, you can see that the opacity is different on this line. And this shows you that the latency is high, which means that we've sent the request, but the server took 1 second to generate the actual response. It didn't return any bytes. And then at the very end, it gave us that little bit of CSS that we needed to render this page. So just by looking at this, you can actually infer a lot of what's happening on the back end and figure out how you can optimize your pages. So this also highlights another property, which is time to first byte, which means that in this case, even though the page itself was taking 1.5 seconds, we were able to flush some of the content early and get the browser to start downloading these resources, which speeds up the overall experience, of course. So I already talked about or covered some of this, but the very high-level overview is that the browser tries to be your friend in the sense that it tries to help you build a fast web page. And the network stack inside of a modern browser tries to do predictive loading of resources and all kinds of things. So when you think about it, as we push bytes to the browser, it starts to tokenize those files. So for example, the HTML file, and it figures out that, hey, there's this style sheet that I need. And at that point, it can actually schedule it onto the network stack to fetch it, which is exactly what we saw in the previous slide. Alternatively, if the parser blocks for whatever reason, so let's say we have a JavaScript file which needs to be downloaded, we don't want to wait because maybe there's a style sheet right after that we could fetch. So we have this thing called the preload scanner, which kind of forges ahead, and it doesn't even do a deep parse of HTML. Instead, it just looks for things like images, style sheets, and JavaScript, and it then schedules those resources ahead. So that's also fairly good in terms of performance. And perhaps the slowest way to schedule something and fetch it from the network is to construct a DOM, get the JavaScript to execute, and then JavaScript is the piece that schedules the resource. So we have a script that schedules, let's say, an image or another JavaScript download. So it's the lowest layer in the stack here because, well, it'll take the longest in general. So this is the trade-off that you have with using, if you're using or abusing even JavaScript loaders. So just keep that in mind. Speaking of network, we also have WebSocket integration. So let me find this demo here. We have a simple website which has WebSockets, and it says socket open. And in fact, if you look down here, we have the WebSocket tab. So we click into that. We see the actual request. This is the WebSocket connection. We can click on this, and we get the actual request headers, the handshake, and everything that's associated. But you can also click into frames and see the actual frames being exchanged between the client and server. So if I type in hello here, you can see that this new frame was sent, hello, the length, and the time. So very useful if you're transferring ASCII text across your WebSockets. Of course, if you're transferring binary data across WebSockets, this is not going to be as useful. But for many applications, this is exactly what you need. So very handy. Another feature that I don't think a lot of people know about is the HAR format. So the HAR format stands for the HTTP archive format. And the way to think about it is the HAR format captures all of the data necessary to capture exactly what you see in the network waterfall. So all of the metadata that's hidden in here. And it's not only just the visible stuff that we see here, but we can, of course, also click into any one of these files and see all kinds of other information. So to capture this file, you can right-click, and you have two options. You can save this specific, these specific metadata for one resource, so for example, a CSS file, or for the entire page. So I'm going to do this. I'm going to click on Save All as HAR, and I'm just going to download it. And it gives me this .har file. And this is just a JSON file which contains all of the information that is embedded in this file. Now, why would I want this, or in this timeline? Now, so often, I'll be debugging a page, and I find some sort of a problem, and I'll mark it up in a screenshot, send it to my buddy, and say like, "Hey, I found a problem. We need to fix this." And then he comes back and says, "Well, that's cool, but I'm missing this metadata. So can you give me more information?" And of course, by that time, I've closed the tab, so that's it. It's over. With HAR files, you have all of the metadata that you could attach to a bug report or send to somebody else. Very useful stuff. So for example, here's a web app. It looks like Chrome Developer Tools. That's because it basically is. Somebody just extracted the code out of Chrome Developer Tools and made it as a web page. And what I can do is I can take the HAR file we just saved, drag it in here, and look at that. We have the entire waterfall available to us. And in fact, you can even click into this file, and there's all of that same metadata. So now when somebody sends you this HAR file, you can just pop it in here, look at all of the data. You have the full fidelity. You don't need to sacrifice on anything, which I think is quite awesome. And not only that, but there's a ton of other tools that you could use once you have these HAR files to build better dashboards, better integrations. You can feed them automatically into tools like YSlow to run performance reports and other things. So Peter and myself actually recorded an entire 1-hour episode on a myriad of different things that you can do with a HAR file. So I definitely recommend that you guys check it out. It's a very powerful tool, and there's a lot of open source projects that are doing amazing stuff with it. So that's a lot about the network, right? And once we've fetched those resources, we actually need to display the page, lay out the page, and provide a good experience once the user is interacting with the page. And the way to think about it is there are kind of two broad components. There is the DOM tree, which is what gets constructed out of your HTML, and then there's all of the rendering information, or the CSS object model. And those two things have to come together in order to create the render tree, which is ultimately what gets outputted to the screen, or painted to the screen, if you will. And the thing to keep in mind is that, generally speaking, the rule of thumb is the further apart you can keep these things, if your DOM object model JavaScript is querying your CSS all the time, that's going to be synchronizing these basically concurrent data structures. And anytime you synchronize anything, performance goes out the door. So that's kind of a high-level tip, but what are we after? We're after a smooth experience, right? We want 60 frames per second on our web pages. And if at this point you're asking yourself 60 frames per second, I'm not trying to build a game here. I'm just trying to scroll on a page like it's nothing crazy, right? Well, not so fast. Turns out you can actually do a lot of things that can compromise on the general performance. So here's an example that I like to use. We have a couple of different tools within Chrome DevTools that can really help you highlight or discover if you have an issue in this respect. So I'm going to go into Google+, and I'm going to enable Show Paint Rectangles. So this is one of these options that you probably don't want to have on all the time, but very useful when you need it. So I'm going to click on this, make this a little bit smaller. And now as I hover over the different elements, you see a little box around all the different elements. And what this box tells you is these are the elements that are being repainted. So the box shows you the specific part of the screen that needs to be repainted. And generally speaking, the smaller the area that you need to repaint, the better. The less work that the CPU and the GPU and the browser has to do. So, hovering just over one link highlights that. But if you pay attention, in some cases, we are actually highlighting not only So in this case, we have this box, but sometimes this entire area is outlined. So that means that on certain interactions, this entire box needs to be repainted, which is probably not the best experience. Now, I haven't looked in as to why. Maybe there's a good reason for why that needs to be repainted in this case. But generally speaking, this is kind of a tip-off to say, hey, perhaps we shouldn't be repainting the chat area every single time that we hover over a link. So very handy. So we can disable that and go back into here. That tells you which areas get repainted, which helps you catch certain problems. Or sometimes, you reflow a style on some other component of the page that you didn't even expect, and you're rendering a lot of stuff that you didn't need to. But you can go even a little bit deeper, and you can go into our frames view, which we'll see in a second, and it will highlight how much time you're spending on painting each frame. So if we do our very basic math, right, we have 1 second, and we want to have 60 frames per second, that amounts to about 16 milliseconds per frame. So that means you have a budget of 16 milliseconds. Now, Chrome itself has to do some work to paint the screen. So generally speaking, let's say we want to stay within 10 milliseconds. And this is exactly what this frame view is showing you. So each section here is a specific frame. And this is the amount of time that it took to paint each frame. So if we stay under this line, and we'll see a better example in a second, that means that we're well within our budget of 16 milliseconds. But every once in a while, we get these frames which take a lot longer. And this causes a skipped frame. So why is that an issue? Well, I have this very simple example here. When I click on this, this line here is just showing you the delay between a timer firing on this page. So generally speaking, we want this to be flat, which means that it's firing on a periodic interval, there's no delays, everything's good, right? And when I click on this button right here, nothing really happens because this button kicks off about 5 milliseconds of work. And as you would expect, we have 16 milliseconds during which we need to finish all of our work. So you wouldn't expect anything to happen, which is exactly the way we want it. Now, if I do the same thing and I click on skip 3, which stands for skip 3 frames, so about 50 milliseconds, watch what happens. All of a sudden, the timer gets this major delay. And that's because we're literally skipping 3 frames. And maybe it's a little bit hard to see, but there's in our animation here, there's a little bit of delay. And to see it really show up, we can click on skip 10, and all of a sudden, the entire animation pauses. Right? So we have our JavaScript running the animation, and we're doing work in the background, or we're kicking off work when we click on this button, and that really causes this jank, which is not a good experience. So a couple of tips there. If you do have work that needs to be done, or for a good chunk of work that doesn't fit into a single frame, 2 things you could think about. One is to push it into a web worker, and the second is perhaps even to split it. So instead of doing one piece of work over, let's say, 100 milliseconds, perhaps you can split it into 20 milliseconds, or 5 chunks of 20 milliseconds. And what that will allow you to do is then allow the browser to inject some frames such that the animation doesn't stop. So you're still doing your work, but you're kind of piecing it together while the browser is painting. So that in itself could be useful. Let's look at this next example. This is an example that we had at Google I/O. So this is a very simple page. As you scroll down, we're just moving the Chrome logos up and down. So let's open DevTools. We're going to go into Timeline, Frame View, and we're going to hit Record, and we're just going to scroll, right? So nothing too bad. Now let's add some costly effects. Try scrolling again. Ooh, look at that. All of a sudden, the frames are taking much longer. And now I'm going to add some on-scroll events. And boy, it really gets bad. So this is our original experience here. We can drill in on one of these frames. Let's actually pick even, there we go. So you can see that this one frame, so we have 3 frames that we're looking at here. Each one of these was taking approximately 100 milliseconds. So correspondingly, the page was scrolling much slower. And that's because we have a couple of different things happening here. First, we have this paint happening, so we're updating the entire screen. And we know that it's the entire screen because you can actually see the dimensions. So this is literally the full screen, and it's taking 15 milliseconds just to paint this entire area. So this is basically our entire budget. So that's a problem. But not only that, we also have this JavaScript callback, so the event on-scroll event that gets fired. And if we expand this, you can see that, boy, we have a ton of different style recalculations. So of course, this is a demo, kind of showing you a pathological example, but unfortunately, this is something that happens very frequently in the wild as well. So definitely check out the frames view. It's very handy to help you debug and find problems on your site in terms of overall experience, to improve your experience. And one last comment I'll make about this is, ideally, you're running at 60 frames per second. Everything is nice and smooth. But if you can't, and that's okay, try and run at a consistent frame rate. Maybe that's 30, maybe that's even 15 or lower. But it's better to be consistent than to jump way kind of up and down all the time. We're very good at detecting changes in that respect, so users will notice that. So stay consistent. Try to do 60 milliseconds or 16 milliseconds. The other tip I have here is similar to the network timeline. You can actually export this data. And once again, you can attach it to a ticket. You can send it to somebody else. You can save it for analysis for later. Any one of those things. And not only that, but you can also import this data into DevTools. So in the network view, we use an external tool to view the HAR file. Here you can import that same JSON right into DevTools and reconstruct this entire experience. So once again, very, very useful. And if you look at the JSON file that gets emitted, it is incredibly data rich. So it has all the information about which JavaScript file is executing, which lines, which functions, what was the heap size before, what was the heap size after, all kinds of stuff. So even outside of DevTools, that data could be used to generate other reports or build other interesting tools. So definitely interesting to explore. On that note, let's move into JavaScript. So lots and lots of pages are using lots of JavaScript nowadays. And a common problem is, especially for long-lived apps that stay open for a while, is memory leaks, where you allocate objects and for whatever reason, they stick around and they're not getting garbage collected. So one tip that I have for you guys is to use the Heap Snapshots view. So let's take a look at an example here. You can find this example on our Chrome developers documentation, but what I'm going to do here is I'm going to go into Profiles, and I'm going to take a heap snapshot. So I haven't done anything. This is just a fresh page, and it's going to capture a snapshot, and in here it just shows you all of the objects that are currently allocated. Nothing interesting happened. Now, what we're going to do is we're going to run this snippet of code, and the snippet of code just is going to create a whole bunch of item objects. So you can take a look at this JavaScript later, but effectively that's all we're doing. We're going to allocate a bunch of objects and delete some, except that we're going to forget to delete some of them. So let's click on this action button. We just allocated objects, and we're going to take another snapshot. So let's go back, click Start again, and now we have two snapshots, right? So of course, once again, we can drill into the snapshot and look at the heap, which is nice. But ideally, we want to see a diff between these two states, and that's exactly what we can do here. We can click on Comparisons, and we can compare it to snapshot 1. So we're comparing 2 to 1. And guess what? You can see that the difference is that between these two runs, we allocated over 10,000 objects. We deleted 9,000, but we forgot 1,000. So 1,000 objects kind of stuck around, and you can expand it, and you can see all of these guys here. So that's our memory leak. So we just ran a diff between the two different heaps, which is very nice, very, very handy for catching these. Of course, you can also watch your memory usage in the timeline as you're recording it, but this is a very handy way of finding the difference. So let's go back. You can also do similar things for constructing DOM objects. So oftentimes, maybe a templating engine or maybe your own code is creating some sort of an HTML or a DOM subtree, which then gets misplaced. You forget to delete it, or maybe you discard it and you don't deallocate it or don't dereference it. And it's going to stick around. It's going to occupy your memory. So similar to what we did just previously with JavaScript, you can identify that via this same process. So definitely check it out. Getting to the audits. So the audit panel has a couple of very interesting features. First of all, you can run an audit to get a sense for what are the kind of easy pickings on this page to improve its performance. So let me go back to this page here. We'll go into audits. And we have a couple of built-in audits, right? There's a network and web page. But really the power of this tool is in the fact that you can easily extend it and customize it, which is something we're going to talk about in the next part of this video. But let's run this report here. You can see that it's giving me a couple of suggestions. It's saying that, hey, you have some resources which are not being cached, so perhaps that's something you can fix. Some cookie, image dimensions. The one I like to highlight here is the remove unused CSS rules. So if I expand this, it tells me that, hey, you've downloaded a bunch of CSS to render this page, but in fact, 78% of it is not being used on this page. Wow. So specifically on this one file, we have 5 kilobytes of CSS, 54% is not being used. And not only that, you can also expand it and see the specific selectors that are embedded in that CSS file that are not being used. So if you're really trying to tune your first load performance, perhaps you can actually separate these files, right? Sometimes it's nice to have one file which contains the CSS for all of your pages, but sometimes it does make sense to split them apart and use them as such. So very handy tool. And for a deeper look at your page, I'd actually encourage you guys to install an extension from the Chrome store, which is Pagespeed Insights. So once you install the extension, you'll find a new tab. And let me go to the CNN example here. I actually just ran this report. So I'm using Pagespeed. I hit run, and it analyzed the page. It downloaded all the resources, and it did a whole bunch of things. And it's giving me a number of recommendations. So you can see that we have high priority, medium priority, and low priority recommendations for how we could improve the performance of this page. So combine images, optimize images. I'll show you one, optimize images. So we found that by running this extension that we could reduce the size of this page by 113 kilobytes, which is quite significant. So that's 31%. And not only that, but we're showing you the specific images and how much you could save if you used a better compression technique, or maybe you need to strip metadata and other things. So one tip that I have is, I don't think a lot of people realize this, we actually also give you the optimized version. So not only do we highlight what was the image that could have been optimized, we also try to optimize it and give you this version. So I can click on See Optimized Content here, and here's the optimized file. You can actually just save this directly to your assets folder and just replace the original file, and there you go. Optimization done. So here's your image optimization built into Chrome DevTools. And lots of other tips, I should say, within the Insights extension. And there's a lot of very good documentation as well. So if some of the recommendations don't actually make sense, you can click on Learn More, and we have extensive documentation on why it makes sense, when it doesn't make sense to do that. Not every optimization is applicable to your case, so check that out. And with that, we're going to wrap up with part 1. So in the next section, we're going to go a little bit deeper into DevTools itself, how we can extend it, and other cool things that we can do with it. Thanks.